This video is part of a series. Complete the previous videos in this playlist before you start this video. The complete playlist information, the material and the code file information is given in the video description below.
Let us understand a few more useful functions that are available in Pandas that you may be using them in some of the projects later on. Let's take a new data set called King County House Price Data. This is the house price data, the number of homes that are sold in King County. So what we have is ID, house ID, and the date it got sold. What is the price for which it got sold? How many bedrooms are there? How many bathrooms? What is the square feet of living? How many floors are there, whether there is any waterfront, whether there is any balcony or the view, what is the grade of the house, etc. What is the condition of the house, whether it is good or bad. Different variables are there. So if you want to analyze this data, let's say if you have a variable called condition, if you want to see the frequency of each house by the condition. Okay, condition means whether it is good or bad or condition A, B, C types. Okay, so you write the variable name dot group by, and then there's a column name is condition, and then count. What does it give is distinct values taken by this variable and what is the count of each of those values. Okay, KC house price dot group by condition and then count. Okay, so this will give us the count by each column. Actually, it is not considering that condition. It is group by condition. Condition is 1, 2, 3, 4, 5, but it is giving the count by each column. I'm not interested in each column. If that is the case, I just want to take the primary key, which is the ID, house ID. Then the condition, the values taken by condition are 1, 2, 3, 4, 5. And condition 1 is of the size 30. There are 170 homes that are with condition 2. Condition 3 is 14,000 homes are there. Or if you want to understand this in a better way, let's say if you take the bedrooms, okay. So how many bedrooms are there? The homes that are without bedrooms, there are 13 such homes. One bedroom, 199 homes. Two bedrooms, three bedrooms, four bedrooms. Usually in US, you have 3 to 4 bedrooms most often, and there are more such homes. And there are some homes with 9 bedrooms as well. Or if you want to see by some other variable, let's say bathrooms, waterfront, a view, waterfront, square feet living, square feet, year built, zip code, latitude, longitude. Maybe if you want to see that by year that house was built, year built. If you do that, then you will see there are so many years and the count, or there is something called grade of the house. Grade, house has different grades, grade 1, grade 2, grade 3, grade 4, and so on, and their count is also given to you. Okay, condition or the grade. Or if you want to, if you are interested not in the actual count, if you are interested by grade, what is the price? If you want to know when grade is 1, what is the average price of the house? When grade is 3, what is the average price? When grade is 4, what is the average price? If you're interested in the average value of the price, so group by grade, but I'm not interested in ID, I'm interested in price, I'm not interested in count, I'm interested in mean. Then what you will get here is by each grade, what is the average value or the mean value. But this whole thing, I just want to round it off because it doesn't look easy to read. So I just put round on top of it. The output that you get is grade. Grade 1, the home's average price is 142,000. Grade 3, grade 4, grade 5. When you go to grade 10, 11, 12, 13, the house price is too high. Grade 7, grade 6, the house price is slightly lesser. Like as the grade increases, the house price is increasing. Now, if you see the condition, is that the same case? Or let's look at that from the bedrooms point of view. Do you think as the bedrooms increases, the price is increasing, the number of bedrooms? There are some homes that are having 33 bedrooms and their house price is this much. These are the average house prices. As the bedrooms are increasing, then also the house price is increasing. And then if you want to see by some other variable, let's say floors, number of floors. As the number of floors increase, it's not the count that I'm interested in. As the number of floors increase, is the pricing number of floors 1, 1.5, 2, 2.5, 3, 3.5. So as the number of floors increase, I think 2.5 is the place where there is a highest price. Okay. If you want to calculate multiple values, let's say if you want to print it like a table, then you can use aggregate function rather than doing it this way. If you want to print it like a table, it's always used to use group. It's always useful to use group by along with aggregate function. So here is how you can achieve this. Let's say if you want to calculate by number of floors, what is the average price of the house? If the floors are 1, what is the average price? If the floors are 2, what is the average price? If you want to do that, so use group by, then use this aggregate function. You group by dot aggregation, and aggregation should happen this way. So I want to know the first count. So give it like a dictionary. So ID, based on ID variable, I want to calculate the count, Okay. But based on the other variable, what's the other variable? Based on the price variable, I'm not interested in the count of the price. I'm interested in the average. So you write the mean value here. Inside a list, you write mean. Okay. So by doing this way, the output that you will get is you will get count as well as the average value, both of them. Okay. Let us see. End of the looks like there is something that we are missing here. Yes, we have to complete that average function. So what are you getting as output? The floors. There are homes that are having only one floor. There are 10,000 homes, and this is their average price. There are floors, 1.5 floors. These are the count of the homes. This is their average price. Okay. Now the price also, if you want to use a roundup function, you can use the roundup function as well. It's not just the one value that you want to calculate. If you want to calculate even multiple values also, that is possible. That means if you want to calculate not just the mean of the price, if you want to calculate minimum price, in that category, when there is one floor, what is the minimum price? When there is one floor, what is the maximum price? So for the price, I want to calculate mean, minimum, maximum. But for the ID, I want to calculate only count. That is also possible. So you will get minimum price of the house, maximum price of the house, average price of the house. When there is only one floor, there are 10,000 such homes. When there are 1.5 floors, these many records are there. This is the average. E plus 5 means e to the power 5. That means like into 1 followed by 5 zeros. Okay. You can also round it off. You can store it in a data frame. You can round it off while printing. But here we can understand directly as well by looking at it. So you can use multiple values to be printed in the output. Okay. Or what else you can do? You can simply store it in a new dataset, KC house price aggregated results. Once you store that and you can print, that will be a data frame. You can print that particular data frame. In that, you can round it off, whatever you want to round off, whatever you want to analyze, that is also fine. If you're interested in only two columns, that those two columns also, you can print them. You can also group by more than one column. Let's say if you're grouping by only floors, what if I want to group by condition as well as floors? Condition takes a couple of values, condition 1, 2, 3, 4, 5. Then within condition 1, condition means house condition. It's a kind of ranking that is given. So within condition, if you want to use floors as well, let us see how do you use multiple columns in the group by and aggregation function. So I want to group by condition as well as floor. So what I'll do is I'll take this as it is, but the new data frame that I'm creating is aggregation 2. So I'll go to KC King County house price data, group by not just floors. I want to group by a list of values. So give that list here. In that list, the first value is condition, the house condition here, the house condition, the home condition, whether it is good condition, bad condition. It's a kind of rank that is given. Remember, this condition is one of the columns in that particular data set. Condition and floors. These are the two values that are used for group by, and the aggregation, I want to keep it as it is. If I give it that way, then what is the expected output? Let us see that output. The output is within condition 1, there are these many floors. Within condition 2, these are these many floors. Within condition 3, within condition 4, within different conditions, these are the floors, and these are the counts, and this is the average value, minimum value, maximum value, everything is given. Okay. Condition. By every condition, these are the floors. Though it is a data frame, but if you look at the column values and the index, that looks slightly confusing. Let's say if I try to print the column values, that this is the list of column values. It is kind of confusing. The first column value is ID comma count. The second column value is price comma mean. The third column value is price comma mean, price comma max. So if you want to access anything from there, you have to give it in this manner. So it's better to change the column values. What you can do is you can take this data frame and instead of those columns, I want to rename the columns. So give the list of columns, ID comma count. I want to simply call it as count of homes. Okay. And then the second column is price mean. So I simply want to call it as average price of the house. Okay. Average price. And the third one is again a tuple, which is price min. I would like to call it as minimum price. Okay. Min price. Then the next one is maximum price. Okay. That is max price. These are the ones that I want to call it as. So I'm just changing the column values so that we can access them. Now, if you look at the columns, just the column names we just change. We can also use rename. Okay. Columns, columns. Here are the columns. Now, this is how the data frame would look like right now. slightly, it looks little neat when you're printing. Even the row index, if you check the row index, that is also not like a standard data frame index. If you look at the row index, how does that look like? The row indexes are also kind of multi-index. If you're not interested in this multi-index, it is useful in some cases, but if you're not interested in multi-index, you can simply use this option called reset underscore index. Reset underscore index. What does it do is it simply resets that index from multi-index to a different index. Okay, reset of index. But that reset index need to come this way. Yeah. So the new index is 0, 1, 2, 3, and so on. Now this table looks just like our any usual pandas data frame. Otherwise, row index was multi-index, column index was multi-index. Sometimes it may be confusing when we are accessing. Otherwise, we can leave the index as it is also after group by and aggregate function. So group by and aggregate, there are some situations you may need that. You may have to group by a particular column and then calculate the values from that group by. It is simply like our SQL group by. It's an alternative to the SQL group by. You can use this as well in the required situations. That brings us to our exercise here. So import this Roseman store sales data. We have already imported it. Understand each and every requirement, each and every question. Try to write the code for answering each of these questions here. Before you move on to the next topic, make sure that you complete this. We can create cross tables and pivot tables in Pandas as well, like the way we do it in Excel, where we keep some categories in rows, some categories in column. We create a pivot table where we can show counts or the average values as the values of the table. We can do that in Pandas as well. Let us start with cross table. What is a cross table? You have rows and columns. So if you look at this data set bank underscore data, okay. So in this bank underscore data, you have a column called job or you have a column called education. Let us see, let us create a cross table versus, education versus default or marital status versus education or job versus education. If you want to create a cross tab, then you use this option pd.crosstab, pandas.cross tab, and your index. What is the index? Index means the rows. Index is from the bank data. From the bank data, I want to take whatever is your rows. In the rows, I'm interested in taking education. And in the columns, so you just need to write columns. My columns, in the columns, I want to take, let's say, whether they have taken a loan or yes or no, whether they have taken a loan or not, simple, in the columns. So I have to use the same structure here, and a loan is what I want to see in the columns. And here is the cross tab. Education, primary, secondary, territory, unknown, and how many people within education in primary. These many people have not taken the loan. These many people have taken the loan. These many people not taken the loan. These many people have taken the loan. It's a simple, plain, simple cross tab. If you want to see the percentages, then you have to do the apply function on top of it. You have to use apply lambda, either row wise or either column wise percentages. If you want to make it a little complex, if you're not just interested in these output, if you want to show the display the percentages, then I would say dot apply function lambda 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 x. Until here everything is common. Now what do you want to do? I want to do the x divided by x dot sum. That means here x represents a row or x represents a column. I want row wise values. If you want to go row by row, first row, second row, third row, fourth row, do you remember what is the axis option? If you want to go row by row, first row, second row, third row, fourth row, for each of these columns, column wise, you have to go by row, you have to put axis. You have to make a side note here, axis equal to 1. Until you are comfortable with it, you have to write. If you want to do row by row, you have to mention axis equal to 1. Then the output is 85 plus 15, 81 plus 19, 86 plus 14 roughly, 92 plus 7. If you want to do it by column, then what's the option? You put x, the same thing, put x is equal to 0, not O. It should be x is equal to 0. Then 15 plus 49 plus 30 plus 4, 100%. 14 plus 59 plus 15 plus 4. If you want to show row by row or column by column, you can also round it off. You can also make it complex. You can also multiply it with 100. You can show anything that you want. Okay. And these columns, like rows and columns, can be anything. That is with cross tables. But if you want to show some more values, if you want to absolutely replace the pivot tables like the way that they appear in Excel, where you have rows and columns and you want to show some aggregated functions, or if you want to use some values, like you want to have rows, you want to have columns, you want to show values, and you want to use different aggregated functions like count, if you want to use aggregate function like mean, then if you want to replace an absolute pivot table, then the name itself is pivot table, pd dot pivot table, pd dot pivot table. Mention the dataset name. Well, here the syntax is slightly different in a pivot table. So mention the dataset name. It's like selecting a column, selecting a table inside Excel. Once you select the data table, then mention the rows in index, then comma, mention the columns in the columns. Okay. Follow that up with values. What values that you want to take? Follow that up with values. What values you want to take, and follow that up with aggregate function. This is what we do in an Excel pivot table, isn't it? You choose the aggregate function, you choose the values, you choose the rows, you choose the columns. So here our rows are education. This is the rows that should be in quotes. And my columns, what I want to see in columns is whether they have taken a loan or not. That's what I want to see in columns. And what are the values that you want to do? I just want to aggregate all of them. I just want to find the count of customer numbers. So if you go to this data, customer numbers is what I want to take in values, customer numbers. And what's the aggregation function that I want to use? Well, the aggregation function is simply the count. Count is the aggregation function that I want to use. That's the pivot table that I want to create, where I have pivot table. Pivot table. Pivot underscore table is the function, right? So here you go, education, primary, and then secondary, tertiary, and then columns are loan, values are customer number, count. Again, you can apply lambda function on top of it, then you can calculate the percentage values as well. That is common. And it's a true pivot table in the sense you can actually show some, like in the place of values, instead of customer number, you can choose some other value. Let's say you can take customer age in the values. You can take customer age and display average age if you like to. So instead of values count, what if I'm interested in average age? So here you go. So the average age of primary education customers who have never taken a loan is 46. Average age of primary education customers who have taken a loan is 44. Here the average is this much, here the average is this much. So you can actually literally replace a pivot table that we used to do in Excel using pivot underscore table option within Python. So when there's a requirement, you can create a pivot table as well inside Python. So that brings us to one of the lab here. So you will be doing the lab related to crosstab and pivot table. So this is our last lab session. We have discussed several options within Pandas. You may not be using all of them, but this is to make you comfortable with Pandas. Maybe you might be requiring to work on something that is totally unrelated to whatever we discussed here, but you should be in a position to do that by doing some of the research, some of the searching on the internet. You should be able to resolve that problem as well. We will close Pandas here. If possible, we will give some more exercises. There are few more data sets that you can work with, but this is good enough to get started. You should be very confident in a project. Obviously, it is impossible to cover every bit of Pandas, every bit of Python. You must be able to understand the basics here, and then on top of it, you have to build it when you're working on a project later on. So go ahead, do this exercise. Afterward, there will be some assignments that will be floated. Once you complete the assignments, you'll get really, really confident on this whole Python. Thank you, everyone.
Continue with the next video in the playlist. We are covering everything step by step. If you have any questions or the comments, please post them in the comments window below.